Hi, if I throw a metal bar and a feather off a cliff at the same time, which one hits the ground first in a vacuum? If you said the metal bar, congratulations, you're human, but you're also completely wrong.
Got a question for you. What's heavier, a kilogram of steel or a kilogram of feathers?
Alright, before we get into the fun motion stuff, we gotta know the basics. First, we gotta know the vector and scalar quantities. Imagine you are running from an aggressive goose at 6 meters per second. That is what we physics nerds call a scalar quantity. Now imagine you are running 6 meters per second directly towards a brick wall. Now that is what we call a vector. A vector has both magnitude and direction, but a scalar only has a magnitude. So then what's the difference between speed and velocity? Speed is a scalar quantity while velocity is a vector quantity. In our aggressive goose example, we just had 6 meters per second is a scalar quantity while 6 meters per second directed towards a brick wall is a vector quantity. Likewise, we also have displacement and distance. Distance is a scalar quantity and it measures the total length of the path you took, while displacement is a vector quantity and it only cares about your starting point and ending point in a straight line. So for example, if you ran 400-meter lap, your displacement is 0, but your distance is 400 meters. Lastly, we got acceleration.
Now what the hell is that?
That's just acceleration. But don't worry, in Physics 1 we read it like this. All acceleration is about is just how fast your velocity changes. Speeding up, that's positive acceleration. Slowing down, that's negative acceleration. Changing direction, yep, that counts too.
Wait, what did you just say? Negative acceleration?
Yeah.
Nah, you're wrong, man.
What? What do you mean?
Okay, the thing is, since acceleration and velocity are both vectors, if they are in the same direction, then we know the state is increasing. That's because you are moving at a speed and accelerating in the direction you are moving. But if acceleration and velocity were moving in opposite directions, like let's say the acceleration vector was negative in quantity because of its direction, and velocity is a positive quantity also because of its direction. If from a positive value we subtracted with a negative value, we can get a lower, or in this situation, a slower result of the deceleration process. Now, can anyone tell me what would happen if both acceleration and velocity were both negative? Would it be accelerating or decelerating?
Accelerating?
Yes, precisely. The reason why is because they are both in the same direction and therefore, quote unquote, adding one another. Now, back to the original question. The metal bar versus feather. The reason why everything falls down is because of gravity. Yes, the thing that Newton made when actually he just discovered it. On Earth, everything, like everything, gets pulled down at an acceleration of 9.81 meters per second squared. Because gravity does not discriminate. It's an equal opportunist. It doesn't care if you're this kind of guy or if you're that kind of guy. It doesn't matter if you're a feather or galvanized square steel. Alright, now let's get into the fun stuff. Motion, which gravity helps with. There are three main types of graphs that the College Board loves to ask you about. Let's go through them one by one. The first is the position time graph. In this, we have a slope that tells us the velocity, but we have to be careful. There are two types of velocity. A secant line is a straight line connecting any 2 points on the curve. Its slope gives you the average velocity between those two times. And a tangent line touches the curve at only 1 point. Its slope gives you instantaneous velocity, the actual velocity at that exact moment. Second, we have the velocity versus time graph. Here, the slope of the line gives you the acceleration in the problem. But the really useful part is this. The area under the curve gives you the displacement, or how far you've actually moved, including the direction of where you moved. And lastly, we have the acceleration versus time graph. For this one, the area under the curve gives you the change in velocity. Now let's move from 1D motion into more cool kid stuff. Let's put it into reference frames, and let's put it into 2D motion. A reference frame is simply the point of view you are using to measure motion. Imagine you're on a roller coaster going 120 kilometers per hour and you decide to throw up your half-eaten sandwich straight up. From your perspective on the ride, the sandwich just goes up and down like a normal idiot. But to your friend standing on the ground watching, that sandwich is flying towards you and is trying to escape you at 120 kilometers per hour, while also going up and down. This is why motion is always relative, and in AP Physics, we normally just set the ground as our reference frame, unless the question is feeling a little bit evil. In 2D motion, here is one golden rule. Horizontal and vertical motion are completely independent to one another.
But how does this work?
It's all about vectors. There's a better but niche way to explain this: dot product. But for AP Physics 1, just think about it like this. Gravity only pulls downward. It doesn't give a damn about whatever is happening horizontally. Now imagine God was a bit bored and he drops an asteroid toward the Earth, and he yeets another one towards Earth at the same height. Both of these asteroids will reach the ground at the same time. Now obviously there are other important kinematic formulas, but they are all in your reference sheet. By all you need to know is that you must separate the two components, the x and the y, put cosine and sine respectively for the velocity, and if you know all the variables except for one, you can find the missing unknown. That's it for AP Physics 1 review. This is the first unit, Kinematics, and if you want to see more of this, we have a Unit 2 video coming up. And we also will have a pack of Unit 1 to Unit 8 questions coming out soon. Thanks so much.